Poles on which a service meter and disconnect are mounted are not considered a structure according to the National Electrical Code. The code defines a structure as something that is built or constructed. Poles, however, are simply installed. In situations where the meter and disconnect are remote from the house and mounted on a pole or poles in the yard, the service is classified as a feeder to the house. Therefore, the relevant regulations are found in Article 225.30 through 225.39 of the National Electrical Code, which specifically addresses feeders. To further clarify, imagine a setup where the service conductors extend from the utility pole to the meter and disconnect. These components, the meter and disconnect, are physically mounted on a pole situated in the yard. From this point, the feeder conductors then proceed to the house itself. Understanding this distinction is crucial for proper electrical installations and adherence to the National Electrical Code. When dealing with electrical installations, especially those involving remote meters and disconnects, it is important to correctly identify the components and their classifications according to the National Electrical Code. The definition of a structure is key here. The National Electrical Code uses the term structure to refer to something that has been built or constructed. Common examples of structures include buildings, sheds, and other similar constructions. However, a pole, which is typically installed or planted in the ground, does not fall under this definition. Now, regarding feeders, these are conductors that extend from the service equipment to a subpanel or a separate building. In the context of a remote meter and disconnect setup, the conductors running from the disconnect and the pole to the house are considered feeders. This is why Article 225.30 through 225.39 is relevant. This section of the National Electrical Code provides guidelines on feeder sizing, overcurrent protection, and other installation requirements. A proper understanding of these articles is essential for ensuring the safety and compliance of the electrical system. Consider a typical residential scenario. The utility company provides the service drop to the property. This service drop connects to the service conductors, which run to the meter. In a standard installation, the meter is mounted on the house. However, in the case we are discussing, the meter along with the disconnect is mounted on a pole in the yard. This remote mounting changes the classification of the wiring downstream of the disconnect. Instead of being service conductors, they are now classified as feeder conductors. As such, they must comply with the requirements outlined in Article 225. For example, the feeder conductors must be sized appropriately for the load they will carry, and they must be protected by an overcurrent device, such as a circuit breaker or fuse. The size of the overcurrent device must also be in accordance with the National Electrical Code guidelines. Furthermore, the installation must comply with grounding and bonding requirements to ensure electrical safety. Another important aspect is the disconnect itself. Article 225.31 requires that a disconnecting means be provided for each building or structure supplied by a feeder. In our scenario, the disconnect mounted in the pole serves this purpose for the house. This disconnect allows the power to the house to be shut off in case of an emergency or for maintenance purposes. The disconnect must be readily accessible and clearly labeled. The National Electrical Code also addresses the physical protection of conductors. Feeder conductors must be protected from physical damage, either by using conduit, cable trays, or other approved methods. The type of protection required will depend on the location and the environment. For instance, conductors buried underground must be suitable for direct burial and protected from damage by rocks or other objects. Additionally, the National Electrical Code provides guidelines on the spacing and clearance of conductors. This is particularly important for overhead conductors, where proper clearance must be maintained from the ground, buildings, and other structures. The National Electrical Code is updated regularly to reflect changes in technology and to address new safety concerns. It is therefore important to stay up to date with the latest edition of the National Electrical Code and to consult with a qualified electrical inspector when planning or performing electrical work. Now, to re-emphasize, the pole itself is not the structure in this context. Instead, the house is the structure being fed by the feeder conductors from the pole. Therefore, the applicable National Electrical Code articles pertain to feeders supplying a structure, specifically Article 225.30 through 225.39. These articles cover various requirements, including the number of feeders, feeder disconnecting means, and overcurrent protection. When installing a remote meter and disconnect, careful consideration must be given to voltage drop. Voltage drop occurs when the voltage at the end of a conductor is lower than the voltage at the source. Excessive voltage drop can cause lights to dim, motors to run slower, and other electrical equipment to malfunction. The National Electrical Code provides guidelines on calculating voltage drop and recommends limiting voltage drop to a certain percentage. To minimize voltage drop, it may be necessary to use larger conductors or to install a separate feeder for each load. Another important consideration is grounding. Grounding is the process of connecting electrical equipment to the earth to provide a path for fault current. Proper grounding is essential for electrical safety. The National Electrical Code specifies the requirements for grounding electrical systems. In a remote meter and disconnect installation, it is important to ensure that both the meter enclosure and the disconnect enclosure are properly grounded. This typically involves connecting a grounding electrode conductor from the enclosure to a grounding electrode, such as a ground rod or a metal water pipe. Furthermore, all metallic parts of the electrical system, such as conduit and equipment enclosures, must be bonded together to create a continuous ground path. Bonding ensures that all metallic parts are at the same electrical potential, which reduces the risk of electric shock. Surge protection is another important aspect to consider. Surges are sudden increases in voltage that can damage electrical equipment. Surges can be caused by lightning strikes, utility switching, or other events. Surge protective devices, or SPDs, are designed to protect electrical equipment from surges. SPD are typically installed at the service entrance and at subpanels. In a remote meter and disconnect installation, it may be advisable to install an SPD at the disconnect and the pole to protect the feeder conductors and the equipment in the house. Remember, the key takeaway is that the pole itself is not considered a structure. This distinction is vital because it dictates which National Electrical Code articles apply to the installation. The conductors running from the disconnect on the pole to the house are classified as feeders, and therefore Article 225.30 through 225.39 governs their installation. This includes requirements for disconnecting means, overcurrent protection, and feeder sizing. It's crucial to understand the difference between service conductors and feeder conductors. Service conductors run from the utility company's connection point to the service equipment, which typically includes the main disconnect. Feeder conductors, on the other hand, run from the service equipment to a subpanel or a separate building. In the context of a remote meter and disconnect, the service conductors terminate at the disconnect on the pole and the feeder conductors originate from that point and run to the house. The National Electrical Code also addresses the issue of outdoor installations. When electrical equipment is installed outdoors, it must be suitable for the environment. This means that it must be protected from rain, snow, ice, and other weather conditions. Enclosures for outdoor equipment must be rated for outdoor use. Furthermore, conductors must be suitable for outdoor installation. The National Electrical Code specifies the types of conductors that are permitted for outdoor use. Direct burial cables, for example, are designed to be buried directly in the ground without the need for conduit. However, these cables must be buried at the proper depth to protect them from damage. When running conductors overhead, it is important to maintain proper clearances from the ground, buildings, and other structures. The National Electrical Code specifies the minimum clearances required for overhead conductors. These clearances vary depending on the voltage of the conductors and the location. For example, higher voltage conductors require greater clearances. The National Electrical Code also addresses the issue of underground installations. When conductors are buried underground, they must be protected from damage by rocks, roots, and other objects. This can be accomplished by using conduit or by burying the conductors at a sufficient depth. The National Electrical Code specifies the minimum burial depths for different types of conductors. Furthermore, underground conductors must be located with tracer wire or other means to facilitate locating them in the future. This is important for preventing accidental damage to the conductors during excavation. Another important consideration is the ampacity of conductors. Ampacity is the maximum amount of current that a conductor can carry without overheating. The National Electrical Code provides tables that list the ampacity of different types of conductors. The ampacity of a conductor depends on its size, insulation type, and installation conditions. When selecting conductors for an electrical installation, it is important to choose conductors with sufficient ampacity to carry the expected load. It is also important to direct the ampacity of conductors when they are installed in hot environments or when they are bundled together. Directing is the process of reducing the ampacity of a conductor to account for these factors. The National Electrical Code provides guidelines on directing conductors. The National Electrical Code is a comprehensive set of rules and regulations governing the safe installation of electrical systems. It is essential for electricians, contractors, and anyone else involved in electrical work to be familiar with the National Electrical Code and to follow its guidelines. Failure to comply with the National Electrical Code can result in serious injury or property damage. Furthermore, electrical installations that do not comply with the National Electrical Code may not be insurable. To summarize, firstly, the poles supporting the meter and disconnect are not considered structures under the National Electrical Code definition. Secondly, the wiring from the disconnect to the house is classified as a feeder. Thirdly, Article 225.30 through 225.39 of the National Electrical Code is applicable to this feeder. Fourthly, all applicable National Electrical Code requirements for feeders must be followed, including those related to disconnecting means, overcurrent protection, grounding, and conductor sizing. Fifthly, understand the difference between service conductors and feeder conductors to ensure proper application of the National Electrical Code. Sixthly, take into account the environmental factors and choose appropriate materials and installation methods for outdoor locations. Seventhly, adhere to the National Electrical Code guidelines for conductor ampacity and directing to prevent overheating and ensure safe operation.